All right, let's jump right in. The world of software development, it's just packed with all these incredible tools. But the most fundamental one, the one that everything else is built on, it's the programming language itself. And choosing the right one, man, it can feel like you're trying to find your way through a maze. But if you get it right, you're literally setting your project up for success from the get-go.
So that's the big question, right? You've got dozens of languages out there. How do you possibly pick the right one for the job? I mean, whether you're building a website, a killer game, or the next big AI model, the language you pick, it affects everything. We're talking performance, how fast you can build, all of it. So in this explainer, we're going to break down the major players and help you figure that out.
Okay, first things first, let's talk about the job market, because honestly, it's a perfect snapshot of what's really powering the industry right now. And look at this. No surprise, JavaScript and its safer cousin TypeScript are just in massive demand. Right behind them, you've got the super versatile Python and the enterprise workhorse Java. But this isn't just a popularity contest, This reflects the massive code bases and entire ecosystems that have been built with these languages. It tells you where the jobs are.
So to really get a handle on the landscape, we got to start with the giants. I'm talking about the languages that basically built the digital world as we know it. They're all about raw power and have this incredible, enduring legacy.
When you're in a situation where every single millisecond counts, you reach for C and C++. These languages were engineered for one thing above all else, just raw, unadulterated speed. They give developers this direct, super low-level control over memory and hardware. And that's an incredible amount of power.
And here's where you really see that power in action. We're talking about the absolute foundations of things like AAA game engines. Think Unreal Engine. Or those super complex financial trading systems, the software running inside your car, even in medical devices. These are all places where performance isn't just a nice-to-have, it's absolutely non-negotiable.
All right, now let's shift gears and meet the workhorses of the corporate world, Java and C#. These two were designed from the ground up for one thing, building massive, complex systems that are stable, scalable, and easy to maintain. Their whole philosophy is that when you're working at a huge scale, predictability is way more important than just raw speed. They are the very definition of enterprise grade.
And their reach is just staggering. Seriously. They're powering these enormous back-end systems for banks and huge retailers, using frameworks like Spring and ASP.NET. For years, Java was the backbone of pretty much every Android app. And C#, that's the language behind Unity, one of the most popular game engines on the planet. A huge chunk of the games you play are powered by it.
Okay, let's move on to the current champions, the languages that are dominating the scene right now. And it's not just because they've been around a while. It's because of their incredible versatility and these massive modern ecosystems that have grown up around them.
And that brings us to Python. Its rise has been absolutely meteoric, and it really comes down to a simple philosophy: make the developer's life easier. It's all about clean, readable code, and it comes with this massive standard library. People always call it batteries included, which basically means you can get up and running and be productive right away.
And because of that focus on productivity, Python has become the undisputed king of data science and AI. If you're in that world, you live and breathe the libraries like Pandas and TensorFlow. They're the industry standard. It's also a total go-to for building web backends or just whipping up quick automation scripts that, just work.
Now, this is really interesting because it shows a huge trend happening in the industry. For decades, JavaScript has been the language of the web. It's incredibly flexible, but that same flexibility can lead to some really nasty bugs, especially in big projects. So what's the solution? Enter TypeScript. It basically adds a layer of what's called static typing right on top of JavaScript. It catches errors before the code even runs, so you get safety and predictability built right on top of that flexibility. It's kind of the best of both worlds. And together, this duo is just unstoppable. They power pretty much every single interactive website you use every day, thanks to frameworks like React, Angular, and Vue. And what's wild is that with something called Node.js, they're not just in your browser anymore. They run on the server too. This lets you build the entire application front to back with one language.
But hey, the story doesn't end there. Not at all. There's a whole new wave of languages that have popped up, and they were designed specifically to tackle the challenges of modern computing. These are the challengers, built for a world of cloud services and doing thousands of things at once. First up is Go, or Golang, which came out of Google. It's all about minimalism and efficiency. The whole philosophy behind it is that modern software has just gotten way too complex. So Go intentionally leaves out a bunch of features to keep the language simple and really easy to learn. And that simplicity, that's its superpower. Especially when you see its built-in tools for handling thousands of connections at the same time, this idea called concurrency.
And because of that, Go has basically become the native language of the cloud. You know those foundational tools that run modern infrastructure, things like Docker and Kubernetes? Yeah, they're written in Go. It's just perfect for building those high-performance little microservices that make up all the big applications we use today.
Okay, now for something that's pretty revolutionary. Rust. Its promise is, well, it's bold. It's saying you can have the raw speed of C++, but with guaranteed memory safety. The core idea is that you, as a programmer, shouldn't have to choose between speed and safety. And the way it does this is wild. It doesn't have a garbage collector that can slow things down. Instead, it has this brilliant system called the borrow checker that enforces safety rules while the code is compiling. It literally makes entire classes of bugs impossible from the start.
And you better believe companies are noticing. They're using Rust for their most critical, must-not-fail infrastructure. You've got Discord and Cloudflare relying on it for their backend services. It's really becoming the modern replacement for C++ and a lot of systems programming. And you see it everywhere in high-performance web stuff, and of course in blockchain.
And finally, we've got Kotlin. Think of it as the modernizer. See, it runs on the exact same foundation as Java, so it can use all the existing Java libraries perfectly. But it gives you a much cleaner, more concise, and safer way to write code. Its biggest claim to fame? It pretty much eliminates the infamous billion-dollar mistake, the dreaded null pointer exception.
Okay, phew, we've met all the players. So how do we actually bring all this together? How do you make a smart, strategic choice for your next project?
Well, it really just comes down to a simple three-step framework. First, what are you actually building? Is it a web app, a data model, an embedded system? The what will often point you to a clear winner right away. Second, what kind of performance do you need? And that's a key question. Are we talking raw execution speed, or are we talking about the speed of getting your idea to market? They're very different. And finally, you have to think about your team. What skills do they already have, and how mature is the ecosystem around the language you're considering?
And this this just summarizes the core trade-off perfectly. It's all right here. On one side, you have C++ and Rust. They give you the absolute highest performance, but man, they come with a steep learning curve. On the total opposite end, you've got Python and JavaScript. They're way easier to pick up, which means faster development, but you do trade off some of that raw speed. And then you've got Go, Java, and C# sitting right there in the middle, offering a really fantastic balance of both.
You know, the one thing you can always count on in tech is change. It's constant. The languages we've talked about today are the absolute powerhouses of right now, but new challengers are always popping up. So the real question isn't just about picking the right language for your project today, it's about keeping your eyes open, looking for the tools that are going to build the world of tomorrow. So what do you think is coming next?